Hello, I'm John Baross, Axis Energy Projects Group. We're based in Aberdeen, and I'm here to introduce our floating wind turbine technology, the Axis Tension Leg Buoy, or TLB. We have patents pending two patents pending, a third one in progress, and we own copyright in related designs dating back till 1999. We're partnered in the development with Offshore Renewable Energy Catapult and Strathclyde University, and we're supported by Scottish Enterprise. Strathclyde have been engaged in hydrodynamic analyses on our behalf, and they have confirmed the stability of our system during installation and operation. If floating wind is an emerging market, and if the potential of wind energy is to be achieved, floating wind solutions will be required. There are a number of companies engaged in floating wind developments, mostly offering catenary mode solutions depicted in the photographs at the top of this slide. These solutions rely on floating buoyant structures to provide turbine stability. They require a lot of steel, and they are subject to movement in all 6 degrees of freedom. Fewer companies are engaged in tension leg technology solutions depicted in the lower part of the slide, where turbine stability is provided by the mooring. Our solution comprises a proprietary modular gravity anchor, tensions, a buoyancy table, and a negatively buoyant central column which supports the turbine, and which certainly provides competitive advantages over other tension leg solutions. The anchor, TRL9, can accommodate all of the mooring loads, and it can be installed without the need of an expensive heavy lift vessel. Stability of the turbine during all phases of installation is provided by a reusable, ballastable installation frame. The slender negatively buoyant flooding column not only reduces mooring loads from the met-ocean effects, it minimises tension fluctuations and peak tensions arising from wave action, thus reducing the cost of tendons and the size of the anchor. Instead, wave action causes water to rise and fall in the column, compressing and decompressing air inside, damping the system and creating an oscillating water column available to facilitate wave energy conversion. For proof of concept, we set our sights high, designing to a 10 megawatt turbine with a total height of over 200 metres and a total weight of 1,300 tonnes. In the 100-year storm condition, we're designing to a maximum wave of 25 metres in hurricane-force winds. You can see from the table at the bottom of the slide that surge in these conditions is a maximum of 7.5 metres, pitch is less than 0.1 of 1 degree, and heave is only 32 centimetres, and the other values are 0. This fantastic stability can only come from tension leg technology. The levelised cost of electricity is reduced by minimising the cost of the system in its installation and maximising electricity generation, given the system's ability to support large turbines and provide combined power. The conventional wind farms depicted in this slide have a total of 151 6-megawatt turbines tied back to a converter platform. We can locate developments of this size or larger in optimum wind locations anywhere in the North Sea or elsewhere. There is a push to reuse oil and gas platforms rather than decommission them. Some of these could have their topsides removed and replaced with converter topsides, with the associated cost savings. There is a potential to link the high voltage DC cable from such offshore developments to the planned Scotland-Norway interconnector at Bodham. We have had 6 very bright MBA students from Aberdeen University working on business models and looking into sources of funding, so we've got some good ideas and information. The Catapult tell us the budget for a demonstrator will be in the order of £40 million, so we are seeking a development partner or partners with the vision and resources to deliver our system's potential. In the meantime, we're seeking an inward investment of around £1 million in order to finance the engineering programme and plan for a demonstrator, and to hire a managing director and a small team to drive the development forward. We have an application in with Innovate UK for model testing, again with Strathclyde University and the Catapult. My prediction is that by the time floating wind is a mature market, the default moorings will be tension leg with combined power systems. Thank you.
Well done.
Yep.
Okay.